think we're live, Jose.
I think we're live here too. Okay,
We're
we
good.
live.
We're
We
good.
live. Think so. Think so. Hey,
Nice.
all right, all right.
How you doing, man?
I'm doing good, bro. I'm doing good. A little bit tired, a little bit sleepy, right? But other than that, I'm doing good. I got the sniffles again,
Uh-oh.
the allergies, right? But other than that, I'm doing good. I'm doing good. Everything. How about you, my guy?
I'm doing good, trying to stay active, play some basketball, try to get ahead this week, you know.
Okay, I see. I see.
I think I'm on a good path to jumping ahead so I can have a lot of time for a bunch of other stuff. So,
Yeah.
I think I think I'm doing good.
Yeah, that's good to hear, brother.
Yeah,
All
thankfully, I know
right.
people are getting sick. I mean, there's a couple people in my circle that are they're not normal.
Hey, what do you mean
And
we're not normal, bro?
like going through some symptoms or
Damn, bro.
some slight,
Damn.
yeah. So I'm hoping that it doesn't come towards me or anything like that. Like, not saying they're gonna give it to me. I'm saying I hope I don't. Whatever it is, I hope I don't get that.
mm,
So
I
I'm
don't
kind of
know,
just
bro.
playing it safe right now, seeing how it
My guy's
goes.
gonna come like in a hazmat suit or something.
Yeah,
Yeah.
I don't wanna. I wanna play it safe.
Yeah, I get you. I get you.
I think this music might be too loud. Give me a second.
Let me see. Let me hear it.
Here we go. But anyways, other than that, um, we got a good stream right now.
Strip
We're gonna be
overhead. Yep.
we're
Yeah.
gonna be starting on trees now, so
Mhm.
that's gonna be cool. And then
Mhm.
let's see what else. I think that's it.
Yeah.
We got 11 problems.
11
We're
problems. Damn.
at 408 subs. So
408. Yeah. Hey, come on, guys. We need 92 more subs. 92 more subs. Uh, 92 more subs to reach the 500 goal. I think we have it on the stream, no? I think on the next scene. We
yeah,
have
we
it
got
where
it.
we have the little counter. We're very close, like 500. We've worked hard for the past, 6 months, I think? Six, give or take.
32 weeks.
32 weeks. Yeah, 32 weeks, to get here. And it's all thanks to you guys. We're keeping grinding, keeping going. And, but yeah, we're here,
Yo, Jose, you
ready
know
to
what I
go.
noticed, man?
Uh-huh.
My eye bags are getting worse, bro.
No, bro, you've been sleeping late.
I mean, I go to sleep like at 12, 1:30.
Ooh, fast,
No,
bro.
12:31, that area.
Really? Okay, I see, I
Yeah.
see, I see.
What do you think, man?
Damn.
What should I be doing
I mean,
differently?
if you're not used to it, I feel like you're gonna get eye bags,
Yeah.
right? Cause right. So I would say just to like sleep in like at 11:30, maximum 12, so you can like get a little bit more rest and stuff.
11:30.
Yes, sir.
What kind of poll should I create right now?
What do you mean? Oh, poor. At what time is sleeping at 12 good or bad?
Oh,
Mm.
I didn't mean it like that, but I
Oh,
just meant
like a
like in
poll.
general, like any poll.
Oh. I mean, that could be a poll. I like it. I like it. If you're down with it too, right?
Should I do how's your week again?
Yeah, for sure. I like that. I like that. How's your week going? Surviving? What was it? Surviving? Uh, bad or good? I think that's how we had it the other time.
Um,
Yep. Nah, dude, nah. I don't get that many under eye bags because they can blend in with my skin,
oh
right?
yeah.
Yeah, but you can see like the little puffiness of my eyes underneath. But like
Yeah.
they're not that visible. But yeah, I try to sleep like around 11:30 or so, just to get some sleeping. Cause even though I sleep 11:30, I still wake up like a little bit tired
Yeah.
after. Yeah, so I try my best to get some energy going in.
All right. Now that we got that out of the way, I think we should start, man.
I'm down. I'm down.
Shift tab. Oh, shift tab. Control tab. Okay, perfect. We're here.
You got it.
Yeah, let me see.
What
Shift tab.
happened? What happened?
So I could just tab through the things instead of like clicking out, you know?
Oh, okay. I get you. I get you.
Yeah. So our first problem
Oh,
is
by the
gonna
way, can you
be.
share your screen? Sorry.
Oh, I'm not sharing it.
No.
Yeah, yeah.
Oh, my bad. Didn't see.
It's all
Dude,
good,
my
bro.
computer is like a airplane right now, bro. I'm wondering what's going on with it. All right. Hmm. Oh, I'll figure it out right now. All right, let's continue.
Okay.
My bad.
So our first problem is gonna be invert binary tree.
Yes, sir. Invert binary tree.
I guess I could read it
Okay.
for you. Given
Yeah,
the
for sure.
root of a binary tree, invert the tree and return its root. So example one for I'm gonna do it like each level. I'm gonna read it like that. Oh no, actually okay. The root is given 4271369 and the output should be 4729631. For
Yeah.
example 2, the root is 213 and the output should be 231. And then if you get nothing, then the output should be nothing.
Yes.
Yeah. So that being said,
Yeah.
let me
Okay.
adjust these. There you go.
Dude, I'm worried about my computer, bro. This thing is gonna.
What's happening, man?
The fan is like going crazy, and I can't control like the fan speed. So it's not. Do you mind if I restart my computer real
Do
fast?
your thing, man. I'll
Yeah.
be
All right,
here.
bet. I'll be back.
All right.
Yes, sir.
All right, everyone. I'm solo right now. So I'm gonna see if I could do this solo. So we got the root, like you said, 427.427.1.369. We want to invert it. I believe we're gonna be doing like what is it called? Is it depth first search? No, it's what is it called, man? It says right here actually. Yeah, depth first search. We're gonna do DFS, and then I think we're just gonna do it on the right side though. We're gonna let me see. Let me think. Or is it breadth first search? You just flip them. Yeah, I think we might be doing breadth first search. Search, and then we're gonna flip the nodes layer, something like that. We're either gonna do that, or we could do a option one. Option two is depth first search, and then with this one though, is I believe you're gonna put the values in a new array, or nah, I don't like that option. So I think option one is probably around what we're gonna try to do. So some breadth first search action. Let me see if I remember the algorithm on the top of my head. So it would be if root equals none, return none. Something like that. And then you do invert tree, and you're gonna do, I think you're gonna do
Yo, yo, yo.
yo, what's
Yo,
up? What's up?
yo. I'm back. I'm back.
All right.
I think I fixed it a little bit. Not sure. But I think we're good now.
Sounds
Let
good,
me
man.
just. Yes, yes, yes. Sorry about that. Sorry about that. Okay, let me. There we go. I don't know. My camera's still working.
Yeah, it is.
Not. Yeah. All right. Bet. I got you then. Alrighty. Yeah. Okay. I'm back. I'm sorry.
All right.
Sorry about that. Sorry about that.
You're here. We're good. We're here.
We're good. Alrighty. Yes, sir. So what's the plan? What's the plan?
So I was kind of like going through what I thought might be interesting, like what kind of approaches we could do.
Yeah.
It's definitely gonna be like a breath first search, death first search.
Okay.
I'm thinking breath first search might make a little bit more sense because
Okay. Yeah.
that's going layer by layer, and you just
Yes.
flip. You would flip the nodes.
Okay. Yep. Yeah. I like that. I like that. Uh-huh.
But I think you
Yes.
could do it death first search. But I was wondering, I was kind of thinking like to myself, how?
Mm,
I think I think the way maybe you needed to incorporate like another you create a new tree
I
with death
think
first
so.
search.
Hmm.
Well, I'm not mistaken. I definitely need to refresh on the algorithms. I know
Yeah, for sure.
I just
Same
need to
here.
do it. I need to do it once, and then I'll remember it from there. Like I just
Yeah.
need a
Same
jump
here.
start
Same here.
because we did a lot of these. So
Yeah. I know for depth first search, it's we can do recursion for that.
yeah,
Yeah. But breadth first search, I'm not sure.
then you could do recursion
Uh.
as well.
Yeah. Okay. Okay. Fair enough. Okay. 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 Mm,
Man, I'm tired. I just got tired all of a sudden. Okay,
really?
I got lock in. I got lock in. All right. So yeah, that's what I was thinking. I was thinking breadth first search or depth first search, but depth first search we might need to create a new tree or something. So that's why
Yeah.
I wasn't really thinking of that.
I mean, breadth first search. We can go right to the left. Then whenever we hit our node, right, we just swap the left and the right,
Yep.
right, and then we go to the number 2. We swap 1 and 3, and then so
Remember,
we go.
it's layer by
Huh?
layer, so it's gonna have
Oh, breadth,
one.
breadth. Okay, breadth first search. Okay, I see. I see. I see. Um, I mean, we can go to 4, right? We switch the children, right? And then we go to 2, switch children, 7, switch children, and then we go each for each level. We can go to each node and just start flipping the children.
I want to see if have we solved this one before.
I don't think so. It should say
Damn, we
on
never solved it.
the
Where?
yeah.
Yeah, I'll say right
It
here.
should right there. Yeah, it should be like attempted, solved, or failed, something like that.
Okay. So actually, I'm kind of messing with this then. If we never
Yeah, me
solved it.
too. Me too.
Hmm.
But I'm interested in the breadth first search though, because I feel like that's the way to do it. That'd be more elegant. If you know what I mean.
Yeah.
Yep.
I'm thinking.
Yep.
2, 1, 3.
Yes. Gonna
Why
check
would you
something
swap
real
them?
quick.
Let me. Can I look up the algorithm?
The breadth first search. Yeah, I got you. I'll look it up here. Python, right? We want to use it on Python.
Yeah.
Okay, I think for this one, we are going to use a queue. I don't know if you remember this.
Like for this problem specifically, or depth or breadth first search.
For breadth first search in general.
Well, in that case, I think we could. I think that. So we put it in the queue, and then we just instead of the queue, it's first in, first out, or something like that.
Yes, first in, first
Or
out.
we'll use
Yep.
the DQ, or what is it called? That goes both ways.
What do you mean both ways?
Like there's a queue and then there's a DQ.
Oh, okay. Yeah. The pop?
Well, basically what I'm saying is you put in 2 and you put in 7 in the queue, right?
Yes.
So it'll be 2 is on the far right and then 7 is right next to it on the left side, right? In the queue, correct?
Yes.
First in, first
Yes.
out. And then, like you said, we're gonna recursively go down, I believe, and those queues are created when we go back up. Instead of going first in, first out, we're gonna get the back of it. We're gonna get the back of the queue and pop from the back, or whatever you want to call it.
Yeah.
And those will be assigned the new children for the node dot left, node dot right. Like,
okay, so you're gonna have 2 and 7, right? You pop 2, and then you pop 7, but in the back, from the back.
You pop 7 first. Well, because the queue, I'm looking at it horizontally.
Okay.
So the 2 will come first.
Uh-huh.
And then the 7 will come next.
Yes.
So you get the last, whatever's last in the line, you pop that one out.
Okay.
Whenever you're done with your recursion. So whenever you're coming back up, that's when we're reassigning the node children.
Okay, I see. Okay, I see. So you put all the nodes in a queue, like 4, 2, 7, 1, 3, 6, 9.
Yeah, I think so.
So you're gonna pop 4, and then you're gonna pop 9, and then 4 is gonna point to 9 and 8.
No, wait. What was the order you said?
4, 2, 7, 1, 3, 6, 9.
No, this is just we're gonna have to. It's gonna for breadth first search. Our queue is gonna be 4, 2, 7, 1, 3, 6, 9.
Uh-huh.
But it's gonna be reversed, so I guess it'll be 9, 6, 3, 7, 2, 4, because it's like I said, 4 is gonna be right here, 2, 7, 1, 3, 6, 9, because it's a queue, remember? So
Yep.
so now 9's over here,
Uh-huh.
right, on the far left. Whenever when we do recursion back up, we're gonna take this one out. We're gonna take the 9 out and assign it to that current current node, which I think it might be right here. I think if it's not, then totally dismantle my idea.
I was thinking, right? It's because I'm not sure if we're gonna use recursion here. Because I have the template here. I can send it to you through Discord so you can show it to the viewers, to the chat. This is of a previous problem we did. Let me see. Here, let me send it to you real fast. Function. Wait. Is it control or alt? Or function? Function. There we go. There you go. Because I don't think the queue is gonna. We're gonna use recursion. I'm not sure if we're gonna use recursion. Because what I was thinking, it was gonna do 4, 2, 7, 1, 3, 6, 9. We pop 4. We switch the children, right? And then we pop 2. We switch the children. We pop 7. We switch the children, right? And then we pop 1, switch the children, pop 3, switch the children, pop 6, switch the children, pop 9, switch the children. I don't know if that makes sense. Yay or nay?
You said you pop 4, switch the children. Is that what you
Yeah,
said?
yep.
Can you hear me?
Rufus, I can't hear you. Hello, hello?
Yo. Chihuahuas.
Hello?
What's up, man?
Hello, hello?
Yo. Look at his face, man. So confused.
Yup, yup.
Yo. Is it me? Is it me, man?
Yup, yup, yup,
Am I
yup.
doing something wrong?
Oh, I can't hear you. What the heck?
Am I doing something wrong, chat?
Yup, yup, yup.
Yo.
Yup.
Yo.
Oh, there we go. I can hear you now. There. My Discord messed up. My bad. Oh, bro, I keep messing up today, bro. Today's not my day.
Dude, you know we have those days, man.
We have all those days,
Sometimes
bro.
we have those days, and it's all good. It's about how you bounce
Yeah.
back from those days.
Exactly, bro. Exactly. All
All right,
right.
man.
Okay.
I think we need to restart.
Okay. Restart.
Okay.
This slow day.
A
You
very
know.
slow day for us.
Yeah. All
Let's
good though.
restart.
All
Let's
good though.
restart.
Like you said, it's the way we bounce back.
Yeah.
So, what do we have?
Okay. Bounce back.
Okay.
Bounce back. So we got. This is how you do depth first search, correct? Or breadth
That's how
first
you do
search.
that first search. Yes.
Breadth
Yes.
first search, correct?
Yep.
So there's a depth first search in which you could go. I'm just giving us some options. You
Yep.
could
Yep.
do 4, 7, 4, 7, 2, 9, 7, 6. Wouldn't that, if there's a way to kind of, because you know, depth first search, you start like you go on the left side and you
Yeah.
come back.
Yeah. Yeah. Yeah.
What if you do it the opposite way? 1, 7, 9, 6, 2, 3, 1.
Uh-huh.
And that, if we could somehow put it like, and that's what I'm saying is like that's how you would do it if you use a second like array or something to store it in, and then
Yeah. Yeah.
you could do it like that. But if we want to do it in place, that's when it gets tricky.
Yeah. Yeah. Yeah.
So I would ask you the question: which option do you want to do?
I feel like in place is gonna be a little bit easier.
Okay, so you think it's gonna be easier?
Yeah.
Okay.
What do you think?
I don't
Clear it
know.
out. Let's discuss it.
I think Death for Surge might be a little easier because
Okay.
you just switch it up. Not easier, but not like the best is what I'm saying.
Yeah.
It'll
Yeah.
be
Yeah.
easier, but not the best. And you just reverse. You just instead of going on the left first, you go on the right first.
Ooh.
It'll
Okay. I
kind of
see. I
just.
see. Yep.
I think
Yep.
it'll
Yep. Yep.
just invert it, but you store it.
Mm-hmm.
So you do your recursion on it, but you're as you're going traversing through each node, you store it into an
You
array,
keep storing it. Yep, yep.
and then you return that array.
Yeah, yeah. That makes sense. Yes, yes, yes.
Or no, never mind. All right, so you want to do breadth first search then?
You tell me, bro. Your decision, your call. I'm good for both.
Well, explain to me why
Breadth
you
first,
think
depth.
breadth first search would be easier.
Okay, so breadth first search, basically, right? We're gonna have them in a queue, right? 4, 2, 7, 1, 3, 6, 9,
Mm-hmm.
right? And every time we pop a node 4, we just have to switch its children. Like from the one from the left has to become the right has to become the left, and that's all. And then when we pop 2, same thing. We flip them, the children. Then we pop 7, we flip the children. Then we pop 1, we flip the children. We pop 3, we flip the children. Pop 6, we flip the children. Pop 9, we flip the children.
Okay.
Yeah, so it's just like flipping the children. Pretty much. Not sure if that made sense, right?
I'm
But
digging
yeah.
it. I'm digging it. So this right here.
Yeah.
Okay. So you have a set.
Yes, a set.
That's the answer.
Yeah.
Or no.
I mean, I got it from another problem that we had, so we might have to tweak a little stuff in here, but yeah, yes.
Okay.
So we have a queue, right? This queue is gonna store the values, the
The
nodes.
nodes, yeah. The
Yeah,
children or whatever.
yeah, and
Okay.
then we have the if statement to check if it's empty or not,
Okay.
right?
Yep.
And then we append the root, right? So we can have something in there on the queue. So we're appending
Oh, that's
4.
yeah, because that's technically one of the
Yeah.
layers. So yeah.
This is yes. So we append the root, and then we run the while loop while there's nodes in the queue.
Mm-hmm.
Or in other words, while we still have nodes.
Yep.
Yeah. And then we say, all right, node q.pop left. So now node is gonna pop from the left, which means it's gonna pop root, right? Because root is the only one there. So node is root. Then we say if node is val, right? Well, for this particular problem, we're checking if node.val is the answer,
Mm-hmm.
or is in answer, we return true, right? So node.val is getting number 4 in this case, right? Because it's the node right now is root. So root.val is 4. And then if the else, right? Here, I think that's from the logic from another problem.
Yeah.
The important thing is the if statements. This if statements is basically gonna check if there's a left, append the node to the left. If there's a right, append it to the right.
Okay, so we could.
Yeah, I think you can delete that if statement. Yeah.
This.
Yes.
Yeah.
And now you can tap it in. There we go. Yeah.
Okay.
So now
Pop left.
here
So
basically,
you pop left, and this is where you do your logic.
yes, I feel like here we could switch the left to the right to the left.
Okay, so you would need a temp,
Yeah, yes, to store the children that we're gonna move. Uh-huh.
Wait. No. Equal left. No. Temp.
I think so. Yeah.
Something like that.
Something like that. Yeah.
And then.
And then it's gonna keep going. So now left is gonna check if there's a left. The left we add it to the queue. If right, we add it to the right.
Very interesting. And then the head. How do we keep track of the head?
I mean the head is still the node. It's still the root. So we just return root.
Okay. All right. Let's see it.
Imagine our work. Ufas.
Oh, it says false. It's not. Oh. Something like that.
Let's
All right,
go.
it's done.
Yes, sir. That's how we roll.
So, what are some similar test cases?
Let's see. Let's see. Oh, right there. 1 and 2, no? 1 and 2. Let's go.
All
Yes,
right, all right.
sir. Yes, sir.
All right, you want to just submit it, man?
I'm down to submit it, brother. I'm
Alright.
down to submit it.
Let's get it.
Come on, brother. Come
Come
on.
on. First problem of the day.
Let's
Nice,
go.
man.
Yes, sir. That's how we do it. That's how we do it.
Good
That's
stuff.
how we do it.
Yeah,
Yes,
I'm not
sir.
messing with this music right now.
No.
Kind of throwing me off.
All good, brother.
Alright.
All right. You know what we have stopped doing? Explaining the problem. So
Okay. Yeah.
I don't know. I'll tackle this one. I'll tackle
Tackle
this
it,
one.
man.
I got you.
I'm here for backup.
I got you. Thank you. So we finished. What problem was it? 223, I think, if I'm not mistaken. 224. 226. Right, invert binary tree. So in order to do this problem, we did something called breadth first search. What breadth first search does is pretty much it breaks the tree into different levels, right? For example, in the first level we have node 4, second level we have node 2 and 7, and the third level we have 1, 3, 8, 9. Right, so this breadth first search, it goes through each levels and it stores each node in a queue. If you guys don't know what a queue is, it's pretty much a data structure where the first element that gets in is the first element to leave the queue. Right, so then, right, we do while queue, right? In this case, we enter this while queue, which stores the nodes and the node left, node right, right? But before that, it pops the first node in the queue, which is going to be equal to node. And then we flip its children so we can invert the tree, right? So we store one of the nodes in a temp, right? So we won't lose it. Then we, on the other side, we point to the other node, this case left, and then the left points to temp, which is storing the other node that we didn't want to lose. And after that, we check if it has a left or right node. We add them to the queue, and we just repeat this process of popping the node, switching its children until we run out of nodes in the queue. So this is how to invert your binary tree using that first search.
Well done. Well said.
Yes,
I agree
sir.
with everything you just said.
Thank you, brother. Thank you, brother. All right, what's next
Check
on the
that off.
menu?
Let's check that off the list. Next,
Yes.
maximum depth of a binary tree.
Ufas. Ufas.
This is literally the same thing we just did, except we're
Same
just having a counting variable.
Oh, that's so true. Huh. No, I didn't think about it. I thought it was gonna be a little bit more difficult. But yeah, that is very true. Yes.
So I guess let's try to remember on the top of our heads rather than
Then
just
copying and
copying the
pasting.
code.
Alrighty.
So
Okay.
we know
So we're
we're
gonna
gonna do breadth first search, right?
yes.
And then each layer we're counting. Kind of just like that. That's kind of just very general. Now, how do we count each layer? Like, what tells us if we're in a new layer? After we're done
that
with
is
the
true.
after we're done with left and right, or
Well, if we're gonna use breadth for search, each oh, that is interesting. Didn't think about it. Hmm. Okay,
Or
I see.
or instead of storing in a queue, you store in an array, and you array each layer, and you just return the length of that full array. Does that make sense? So it's gonna be like this, and the first layer 3, and then you got 9, 20, and then you got 15,
15 and
7,
7.
and then
Okay.
you know you got 3 layers because
Yeah, you
you
have.
got
Okay,
three
I get
different
you.
arrays.
Okay.
But is that optimal? We're trying to be optimal now. We're trying to get away from that beginner tag. We wanna get a more advanced tag.
The
So
advance.
um
I remember. I think we did it on this problem, and some of our viewers helped us to solve this problem, and it's similar to what you just said, right? And it's still using depth first search. No,
breadth or
breadth first
depth?
search. Breadth.
Okay.
Breadth first search. But instead, we save the layer we are in. If that makes sense. Like instead of just adding the node, we add a tuple, what they call them, where we have two values,
Okay.
right? I'm not sure how we did it, but I remember we did it. And it was pretty cool. The solution was pretty cool, and one of our viewers helped us solve it.
Well,
But it works similar to what you said.
could we do depth first search? I'm wondering. I'm just curious.
Yeah.
I have a
Yeah,
very
let's
curious
explore
mind.
the idea. Yeah, let's explore it. I'm good for
So
that.
it would be 3, 3, 9. Oh no, yeah, 3, 9, 20, 20, 15, 7. Or how does it go?
It's
3.
because there's three types. There's three types. We can do, I think it's the in order, pre order, or post order, if I'm not mistaken, where you can get the parent, then the left children, then the right children, or go to the left, parent, right, or go left, right, parent. So there's three types of of depth
Traverses.
first search. Yeah, traverses. There you go.
I think breadth first search might be the move.
Yeah, but I mean, I'm down to explore how to do it depth first search because that could be a little bit easier. Hmm. Mhm.
Nah, I think breadth first search.
Breadth first search. All right,
Yeah.
breadth first search. It
Okay.
is.
So I guess let's just kind of just write down the code first, and then we'll figure out where we could modify it, right?
Yeah, I'm down with that. Yes,
Okay.
sir.
So
Alrighty.
um,
It's first we have to do. We have to create the queue,
you
which it goes.
can we just do an array?
No, it's DQ. I think DQ parentheses because a DQ works. An array works as like an array queue, but DQ is a little bit more specific. If you wanna.
But what I'm saying is,
Uh huh.
if we want to store it,
Oh yeah. Oh yeah. We have to create. Yes. My bad. Got a little ahead of myself.
but now I'm thinking, yeah, no, it would work. Okay. So like this, right? And
Let
then
me see.
if root equals none, return none. U dot pen. How do you pen an array?
Um. Well, that's the thing. That's what we have to use a DQ. Or, let's see. You can append an array. Yeah. Mm. It's because the Q and the DQ. I feel like the Q and the array they're two different things. Because the Q is gonna store all the nodes, right? And the Q is gonna store the level, and the array is gonna store the levels. I don't know if that makes sense.
So we can have a queue and an array at the same time.
I think so. I think yeah. I think that'll be a little bit more. I think it's just with. I think you have to remove the last U and E because it's QU. QU. Yeah.
Calm me down
Right.
next time.
No, bro. What do you mean? I'm not calling you dumb. I would never call you dumb, my boy. What do you
It's all good,
mean,
man. Don't worry
bro?
about it.
I get.
I got the hint. I'm joking.
Okay.
So
Um,
then you do q
we appended, yeah.
dot add. What was it?
Append. I think. Yeah, append root. Yeah. Ooh, I remember how we did it last time. Okay. So on the root, we're gonna store a value, which is the length of the array. Well, the level it is right now. So root right now is gonna be at level 0, right? So it's gonna be parentheses root comma 0. Yeah, yes, sir. Right there. And then you're gonna pop it. You're gonna set node and level, right? Because you're gonna pop pop left. Yes. And is I think it's lowercase l, by the way. Yeah. And then you're gonna get you're popping a tuple, so you have to save it on 2 variables, which could be node and level, right? And then ufas. We're gonna say if the length of the array is the same level. Wait a minute.
I guess you don't even need the array. I guess you could just count. If you could.
Well, that's the thing, because let me see. I think it's root level 1. Because if the length of the array doesn't match the level, then we have to add an array and append that node into that level, right? And add a +1. Does that make sense?
Yes.
Yeah?
I think so.
Yeah, because right now the array, right, we have 0 levels. There's nothing in there. But we want to add a new level, right? So we have to check if the level of the node matches the size of the array. Because the size of the array is going to give us the amount of levels we have in the binary tree. Just the way you did it on the example where 3 is level 1, 9 and 20 is level 2, 15 and 7 is level 3, right?
Yes.
So 3, in this case, would have a level of 1. Since array the length is 0, means that we have no levels, but level 3 is level 1. We need a level. So we have to check, all right, does the length of the array, which equals 0, match the level of 3, which equals 1, right? If not, if they don't match, we have to append an array to the array, right? So now the length of that array is 1, and then we can append the 3 into that level. Yeah or nay?
Yeah. So you check first. Like you check first if that level is there. If not, you append the array, and then after
Exactly.
that you append the value to that array.
Yes.
Okay.
Yeah. So here we have to check if the array the
length.
That's Java.
If array length is less than
equal
or level. Equal.
Yeah, I think it's equal to level, right? If so, right, we're gonna append it to that level specific. So it's gonna be r array at position level dot append the root. The root, yeah, just the root, I think. Just, yeah.
But this is not giving it an array though, right?
Well, the level is gonna go to array, right? It's gonna get the array at whatever position it is, right? And then it's gonna grab that array and append the root to the array inside of that array, if that makes sense. Because our level is gonna turn into array. For example, let's put an array in there, right? And let's say level, right? And I think we have to subtract level minus 1 because it's indices start from 0. But let's say we have a level 1. Uh-huh.
This is, there's nothing
That's
in
the
here.
array. That's nothing in here. That's 0,
Yeah.
right?
No, I don't. Is it 0 though?
Yeah, because we have nothing in there. There's no
So
elements.
you're
There's
saying
no.
at array
Well,
0 append root.
let me see. Well, that's the thing. If it matches, if it doesn't matches, we have to append an array.
Well, it is gonna match because level 0 and length is 0.
Well, that's the thing, right? We have to change the root at where we appended the root into a 1.
Oh, okay. So this is 1 now.
That's a 1. Yeah, because it's a
Oh,
level
okay,
1.
Okay.
Yeah.
So,
Then we're gonna check.
So I see what you're saying.
Yeah.
Now else
Else,
if you
right?
append an array,
We append an array
into array.
Yes, I think so. Yeah. R dot append an array.
Is that how you do it?
I think so. I'm pretty sure.
Okay.
You want me to check?
Yeah. Let's check that.
How to add an element to an array in Python. Append. Yeah, append method.
Let's check that. All right.
Append.
So
Append.
just like
Yeah.
that?
Yeah, and now we have to put the root into that array. So now we're gonna do r at dot level append root. Yes. And I think the levels we have to subtract -1 because now we're working with indices. Yeah. And also on line 30. Am I making sense or am I just talking gibberish, bro? Because I feel like I'm
you're
not.
making sense.
Yeah. Okay.
I wonder, can we switch this into like something better? I wouldn't want to like run that function each time. Can we just store and just increment it as we go on?
I think so. Yeah. Yes. And then it's gonna be on the else is where we're gonna extend. Yeah.
That.
Yep.
All right. So once all this is done, then you do node.
We're gonna check if we have a node, and then if so, we add it.
You don't do if node dot left, right?
No, you have to do a node if that. Yeah, because we have to check if it exists.
Okay, if it exists,
so,
then what?
Then we append it to the queue now.
I see.
Now we're gonna append the node dot left +1 level +1 because now we're going to the next level, right? Because we went now it's the children, so it's another level. Exactly. Then I think we return the length of the array. Or we can return length, I think. Yeah. Yes, sir. Okay. That worked. How do you feel about it?
I feel pretty good. I'm wondering.
Yeah?
I'm wondering right now.
What you wondering about?
Like, do we need to put it in a new array? I wonder if there's a way without.
Mm,
Like, what's.
I mean, we can check the levels because every time we append to the queue, we add a level, right? So we can do something with the level, and hmm, we can check the length of the queue and see, hey, if we're the last one, right? If we're the last element in the queue, right? Before we even do any of the other work, right? We check if we're the last one of the queue. If so, we return my level, the level that I have right now currently, right? And then we just get the level, and that's pretty much it. Because the level is incrementing each time we have a children,
Mm-hmm.
right? If we get the last children or the very, very last, if we get its level, that's gonna give us the level we have. The level, the maximum level, the depth.
Yeah.
Yeah, but we have to check if it's the last one in the queue.
Well, we know if it's the
But
last if right here. Oh, hold up. Right here, right?
yes, I was gonna say that. Yeah, we have to check it if it's there, because if they're both, wait a minute,
This is
not
gonna reach
quite,
first.
not quite though. Wait, would it? Yeah, I don't think
No,
so.
not quite because they could have
Not quite.
like
Exactly
this
like
right here.
9. Yeah.
Yeah.
Uh huh.
Okay. Okay.
We can go to 20 and 15 and 7.
Wait.
Uh huh. Or we can just store the level in one a
No, you're right.
variable
You're right. No, you're
and be like, we can store the level of each variable, and yeah. For example, in each if statement, it's gonna equal length or level will equal, or max depth will equal level plus 1 every time we add a new children, and that's just gonna keep track. It's like a counter where every time we add a new children or a new children, it's gonna increment. So we can also do that.
But that's not gonna give us the right amount. That's gonna give us more.
Well, you do it after you increment both children. After you do add both.
Right here.
So yeah, so it's gonna be like max depth will equal level plus 1. Let me see. Let me see if that makes sense. No, I think it's just gonna be level. Max depth. I think it's gonna be equal to 0. Max depth is gonna be equal to 0. So it's gonna go 0, 1, 0, 1, 2. Yeah, I think that works. Yeah.
What's up?
Hey, what's up, Kyra? Welcome to the stream. Welcome to the stream. Oh no.
I'm saying this should work right here.
I think we have to delete the +1. If I'm mistaken.
This one right here?
Wait a minute. Maybe
What was the...
it was giving us one more. The output was 3. We were getting 4. Yep. Yeah.
Wait. Hold up. Wait a minute. Output.
I think you have to subtract the +1.
So not this?
Yeah. Think so. Not sure. Yes, sir. Okay. We could test it out with different test cases.
Wait, how does...
It's because the level is being determined by the node you're working with, right? So you're gonna get the first node is gonna equal level, right? And then you're gonna get the children. Since both of them have the same level, right? Max depth is not gonna change, right? So it's gonna be 0, 1, right? Because it's the head. When you go to the children, it's gonna equal to 2. Max depth is gonna equal to 2. When you go to their children, it's gonna equal to 3. So max level is just being set to the level of the current level that we're working with. It's not being incremented, it's just being set to the current level we're in. And since we're already tracking the level by adding the children, right? Max depth just has to equal to the level. We don't have to move anything.
So we're gonna be here. Max
Uh-huh.
depth equals
The level of 9.
Would it be 2 or 1?
Yeah. Uh-huh.
2?
2.
2.
Uh-huh.
And then once you're done with this one, you're over here. Max depth still gonna be 2.
Exactly.
Then,
yes.
Okay, I see.
Yeah.
Yep. Very interesting.
Very
So now
interesting.
our code
Very
just looks like this. If it's
yes,
right.
sir.
If it's right.
If it's right. But I think it's right. It works flawlessly.
So far. With 2 test cases.
Far.
Let's see. Any test cases down here? Bear with me.
All good, buddy. All good.
I don't like this one.
Me neither. Let's go. Too
back
easy.
To back.
Too
Can we get a...
easy. Oh, because we returned none. It has to equal to 0. Oh my god.
I don't know who did that, but whoever did that...
Use test case? Let's see.
Whoever did that should be fired. Whoever did that should be fired, man. I don't know who did that.
Man, bro.
Bro, I can't believe I did that, bro.
I didn't catch it too, so no, you're good, buddy.
You serious right now? That's crazy.
But hey, back to back though, back to back.
No, it
Minor
wasn't back to
mistakes,
back.
minor mistakes, minor
We
mistakes.
failed it. Now what's our... Oh, hold up. How do I go to my our profile?
Oh.
Now we're at 65%, man. Come on now. Lock in. That's what I'm trying to say, man. Lock in. Look at us. We're ranked 1,000,000.
Rank 1. Damn,
427,726, man. We're trying to get underneath 1,000,000.
We have 61 problems solved in our entire 32 streams. 62 if you're counting the C one. 62 problems solved.
Too hard. Oh, 20%. Oh, appreciate it. So it gives us a percentage for each difficulty. Huh. Very interesting. All right.
Alrighty. What you
Maximum death.
wanna do the one
Let's do
one more?
one
One
more.
more?
Let's do one more.
One more?
Get
Alright,
one
I'm done
more
with
in.
one more. Ooh, fast.
So we did this
Okay.
one. We did this one. You want to explain it or you want me to explain it? I can explain it. Or you want to?
You can explain. Yeah, just 6 turns.
Okay. Let me get a visual going. Okay. For 104 maximum depth of binary tree, our goal here, if you look on the left hand side, is to get this. The depth is how far it goes down. So if you look at it as layers, this could be layer 1, this could be layer 2, and this could be layer 3. So the depth will return 3 based on the way the tree is formed. You might be wondering, well, how do you get each level or each layer? That's when the algorithm breadth first search comes into play, and it basically is going to store each children into a queue, and you get to know the each individual layers of the children. The way you do that is you're going to check, okay, you're going to get the root, and you're going to pin into the queue, and then while there's stuff in the queue, you're going to keep going to check to see if there's children in that node in the queue. So you pop what's in the queue, which is 3, and then you also got the level, which we put beforehand, which always starts at 1. So now you got the node 3 and you got level 1. You check if the node has a left child, which is 9, then you want to add that node to the queue. But when you add it, you want to increase the level +1 because you're going down, so this is level +1. Then you recursively do that. So now you're right here. You pop it, and then the level is level +1, so it's 2. So you're at node 9, and then level 2. You check, does it have a left child? It doesn't have a left child. Okay, so then you go, does it have a right child? It doesn't. So anyways, you want to do that recursively for everything. So by the time you're done with this, then you're over here on 20 because that's going to be the next thing right here for node number 3. You check, does it have a right node? It does have a right node. It's 20. Add it to the queue. You add the level. You keep doing that. But the trick here is when you're at each level or each depth level, you want to equal it to the current number that level is. So if the level is 2, max depth equals 2. If you go down even more and the level is 3, max depth equals 3. So it's always going to be at the highest depth. This variable is going to store that. So then when everything is done, you return the max depth, and that's going to be 3 for this one.
Yes, sir. Yes,
I
sir.
need to work on
I
my
like it.
explanation skills
No.
more.
You did it pretty good. You did pretty
Nah,
good. I liked it.
I'm done, man.
Yeah.
How do we do it?
Yeah.
We did it before, so let's see how we do it.
Yeah.
Oh, it looks like
June
it's
11.
the same,
Same.
almost
Okay.
identical. Uh, yeah,
You see? Yeah, we did the. I remember it was this one. Uh-huh.
very interesting.
Very interesting. Hey, but we managed to remove all that stuff
Yep.
and just do simple, straight to the point, saw the pattern, kept it, and let's keep going.
Yeah.
All right. One more.
Same tree. It's
One
this
more.
one.
Same tree.
All right.
Okay. How would we do this? Okay, let me read this one. Yeah.
Okay.
Yeah, I got you with this one. So we're doing 100, problem 100, same tree. It's an easy, and it says the following. Given the roots of two binary trees, P and Q, write a function to check if they are the same or not. Two binary trees are considered the same if they're structurally identical and the nodes have the same value. Okay? For example 1, we have 1, 1, 2, 2, 3, 3. Example 2, we have 1, 1, 2, 2. But since they're in different childs, one of is left, one of them is in the right, they're not the same. Now example 3, they have the same values, but they're flipped around. The children are flipped around, so it's not considered identical. So this is problem 100, and let's see how we solve this one. Okay. How do we do this? I think we solved it already, no?
Yeah. Well, you could I'm thinking about how you would do it at the same time. Like you're over here, and then you're pointing over here, or something like that, and then you're doing the same path, and once the path misses, then you return
It's
false.
false. Yep. We can do a depth first search.
Yeah.
Where we can start both at the same time, have them in the same function, and just go left 2, left 3, and whenever they don't match or they're not equal to each other, right? That's where we cut the ties and we return false.
Yeah.
Yep.
Okay.
I'm down with that. So, all right. So we got three traversals. Which ones do you want to do, my guy?
Let's do
the
pre-order.
Pre-order? Okay.
For search, pre-order. I think I remember the algorithm now.
Yeah.
I think.
Same here. It's kind of vague right now, but let's see.
Oh.
It's recursion though. This one is recursion.
Let me see. I know this. It's not gonna apply right now. If root equals none, return none, and then you do while root, then it's or do you gotta create your own function?
I think to my understanding, we have to create our own function.
Root.left, DFS, something like this. Root.right. Something along like that.
You're in the right path. Yeah.
So we create our own function then?
Yes. And I don't think we need a while loop though. And then that goes in there. Yeah. I like that. And then what do we want to do? Yeah, that's it. You can print it out. You can print root.val on line 18, and that works. And then just call the function with the root, or with a q, or p. Yeah. There you go. And I think that should work. Pretty sure. Yeah. 1, 2, 3. Yeah or nay? Yeah. Okay.
So how do we do these at the same time?
Oofus.
I mean, obviously we could store it into an array and then compare.
I was gonna think the same thing. We can store it into array, but no.
We're not trying to be a beginner
that's
right
child
now.
play. Child play.
We're trying to do this the optimal
we're grown
way.
men.
We graduated pre-K.
We in kinder now.
Yeah, we're in kinder, bro.
No naps now. Did you kinder when you were in pre-K? Would you take naps?
Yes.
Were you in kinder? Yeah. I would do that, bro. I think it's pretty nice.
Not kinder.
Kinder. Yeah, it was pre-K. Yes. I remember one time because the teacher would like turn on the lights and I think some kids wouldn't wake up. We would grab like the mat, and just like yank it out, like their heads would just like bounce, like, boom, right on the floor. That was pretty nice. That was pretty cool, bro. And some people are like, not
Bro,
to be offensive, bro, if they
no.
have some bigger heads, bro, they'll be like, boom, boom,
What are you
boom, bro.
talking about? What?
Bro, that was funny, dude. It's like,
What do you
like,
mean?
bro. Hey,
So,
if you don't wake up, we wake you up.
whoa, what pre-K did you go to? That's like
Bro, what do you mean, bro?
what? You couldn't
Yes,
sleep?
bro. No, like, yo, we would sleep, but when it was time to like wake up because it was time to go, some students wouldn't wake up, so we grabbed like the little mat we would get. They would the mat, and we just like jank it out, like slip it out, and their entire body would just stay there, and their head was just like boom, right on the floor,
Yo,
head to
come,
floor,
someone come get this guy, man.
like a boom,
So
bro. That was funny, bro.
you might have caused some
Some
brain
concussions, some
injuries to
brain damage.
some
Yeah, yeah,
4-year-olds, man.
yeah,
I'm
yeah.
gonna report you.
Hey, nah, bro. That was the old me. That was the old me.
That's crazy. You're
I'm
a
a
trouble
reformed
kid.
person.
Wow. That's
Ah,
very interesting. But you're over here, good times, good times. You're
good
over here
times,
like
good times.
reminiscing, man. Like you want to go back to that.
Bro, that
That's
was
what,
funny, bro. Their heads would bounce, dude. You just get like, oh, boom,
you
bro.
want. You want to know a funny story?
Uh-huh.
I don't know if I ever told you, but I think it was Kinder, right?
Uh-huh.
And or maybe it was even pre-K. I think it was pre-K. And we were all sitting outside and crisscross applesauce. There was like a speaker, right? I guess it was like a
Yeah,
junior
yeah.
guy, or it might have even been the janitor. It was seen as a speaker, like, oh, come listen to the speaker or whatever. And like it's very hard to keep a child like still, crisscross
Uh-huh.
applesauce, just paying attention. What I was
Yeah, yeah.
doing while the speaker was talking is I was grabbing the acorns on the floor because we were
Oh,
outside. There was acorns,
uh-huh.
and for some reason, this particular acorn I wanted to put in my nose.
Oh, yeah,
So,
okay.
and you know how the acorns they had like the little stem, the
Yeah,
little
yeah, yeah, yeah.
stem on the outside.
Yeah.
Well, I put the acorn in, and I was gonna pull the stem, like to pull it out, right?
Uh-huh.
Like, and when I was trying to pull out the stem, it came off the acorn.
Oh,
So when I was
no.
pulling, the stem came out, and the acorn was still in my nose.
Okay.
And
Okay.
I got so scared. I was wondering like, how do I get it out? So I was like digging my my fingers like through my nose and trying to get it and
Yeah.
stuff. And I got it out, but now I'm realizing I could have just went from the top and just like
Yeah, from like the
took it
top, you just
out.
like squeeze down
Yeah, and I didn't. I was trying to get it from the
from the
nose.
bottom.
Yeah. So, anyways, it was I
Damn.
was scared. I want to tell you, like I was scared.
Yeah.
I
No,
was
I
like
get you. I would be scared
panicking.
too, bro. I would think like I would die. Like I would start breathing. You know,
Yeah, I was panicking. I didn't know what to do. So, anyways, that's about it.
bro. Kinder days, bro. Those were the good old days, brother.
Yeah. Anyway,
Good
sorry,
old
sorry, sorry.
days. All good.
We're
All good.
back.
All
We're
good.
locked in. We're locked in.
So,
So, yeah, about that. How can we do this at the same time?
all right. So we can have two routes, right, and traverse, right. Have BFS to accept two routes, right, and then yeah, we can do that. We can have BFS to get two routes, and then we check if we checked if the children has like if they both match and stuff. Like if route 1 and route 2 are the same, yeah, and all that stuff. Uh-huh. Uh-huh. Yeah, and then we check, well, first we check um if they exist, right? If route 2 equals none, 2 and Or I'd say or would be a
Yeah.
little bit better. Yeah. That way, if like if one of them is not equal, is doesn't have anything, we stop, right? Then we check the value.
Wait.
Okay. Let's see.
If one of them is none and the other one isn't, we need to return a false.
Yes, we have to return false.
But if both
Because
are none, you return none.
very smart, very smart. I like that. Yes, sir. Keep that.
Keep that as in.
Oh, I think we have to keep. We have to do 2 if statements now. Or we can equal them each other if root equals root 2, right? That way we don't have 2 if statements like root equal root 2, which means that it has the same value. The same, I think so.
Wait. Our problem here is if both nodes are none, you return none. Because you do recursive back up. But if one node is none, return false. Because that means there's an issue there.
Yeah.
So
yeah.
we are trying to do multiple if statements to try to see if there's a way we could just put it in one.
Mm-hmm.
But if we can't, then we know that we just create another if statement that states that.
Yeah, for sure. Yes.
So what's a way we could do it in one if there's a way?
I would say equaling them to each other, because I think if you equal 2 nodes, it's gonna check the value, and the value. So it's either it does have a value or it does not have a value. So if root has a value and root 2 doesn't have a value, it's gonna return false. It's gonna return false. But if root has a value and root 2 have a value, but they're not the same, that returns false. But if root and root 2 have the same value, it's gonna return true, or in this case, none. So I think the if statement, if root equal root 2, is gonna check the 3 things. If I'm not mistaken. J or nay? No? No. Yes.
I don't know, because if this is null, and this one there's something, then we need it to return false.
Yeah, well, we do an else statement.
But that means it's going to either return none or return false, but we need to check the values.
Well, I think the root checks the values, though. The if statement checks the values.
This one.
Yeah.
That doesn't. It checks the node.
Okay, so we can do an end statement, no? And we can check the values? Well, what's your original plan? Yeah, I think...
Well, honestly, I didn't have an original plan. But I know that if we do an else return false, then obviously we know that it's going to return one, it's going to return none, or it's going to return false after once this. We're never going to hit this.
Okay, yeah.
And this doesn't check the values either. Because if it did, it would be that val.
Okay. Do you think with an end statement we can check the values? J or nay?
So, if I'm looking at this now, if root equals root 2, that's
Or
gonna.
why not? Let's try it out. Let's do a print statement outside the function to see what the if statement is or something. That way we can have like a better idea of what to do.
What do you mean print statement?
Like do if root equal root 2, then print yes, and then else print no.
Oh, sorry.
All good, all good.
You just wanted to see me fail, didn't you? Huh?
No, what do you mean,
You
bro? What do
just
you
you just saw
mean?
the error and then.
No, because last time I told you something about your error, you said, "Oh, bro, what the heck, bro? Were you pointing out my errors, bro?" I'm like, "All right, bet I'm gonna
Yeah,
let you
you're right.
fail."
That's all
Nah, I'm
right. You're
kidding.
right.
I'm
You're right.
kidding.
You're right.
I'm kidding.
Um.
All right, I'll take to comment out the entire function. Yeah, just so we can have a little bit of a yeah. You, bro. It said no. So P and Q, okay. Because they're not the same node. They have different heads, different everything. Okay. So we can't do that. I would say just to do the if
So
statements, no?
yeah, I guess we would have to do
Yeah.
that. Um if root equals none and root 2 equals none, return none. If root equals none and root, wait, no. If
You can say if root equals none or root equals none.
because one of them has to not be none based off
Yeah.
this.
Mm-hmm. Turn false.
Yes. Yes. Root of val equals root 2 dot val. Then oh, then don't you keep going?
Yes. Did I think about it? Okay, let's see. Let's think this through. So if they do match, we want to keep on going, right?
Yes.
Okay. So why not we say if root dot val equals root dot val and root equals none and root equals none. If those conditions are met, continue, else return false. Because the first if statement, right, we want to continue, but as soon as we hit that none, it's gonna jump back. Wait a minute. No.
Well, I don't think you could do that here, and I think you might have found why, but because if they both equals none, we gotta we gotta go back in the recursively go
Okay.
back.
Yep.
And I don't know if we could go forward and go back in the same if statement.
Yeah, I get you. Yeah, I think I like it. Yeah, but instead of none, returning none, wouldn't we return true?
Say that one more time. Sorry.
Would we return true
If what?
instead of none?
No, because right here, like I don't know if there's an example, but if the left side is shorter than the right side, you're both gonna get none, and you still gotta go back up and then come down over here to the right side.
Okay,
So
okay, okay. I see, I
that
see, I
wouldn't
see.
necessarily mean it's true yet. I don't think.
Okay, okay, okay. I get you, get you. All right, I think we can run it then. I
Let's
like
see.
it. We have to call the function though.
Oopsies. Um.
PFS and PQ.
Wait. Doesn't it return true right there?
Mm, okay.
Yeah or nay or no?
I think so. Yeah, yeah, but I think we have to return whatever BFS is getting. So we have to return BFS P of Q for the
Okay.
function.
Okay. 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 Hi, Chihuahuas.
Let's see. Case
Maybe it's
2.
this.
Maybe. What's case 3 returning?
Or
Yeah, it might be. It might be.
see, look. First of all, hold on. Perfect example. I want to go to the thing that's on the right side of it. How can I? Oh, right here. Never mind. Like right here. Wait. Okay, never mind. Never mind. My bad. My bad. I'm
Bro,
trying
you're
to find.
waiting for that moment. You find
I'm
that
trying to
bug,
find.
bro.
I'm trying to find a
You're
bug. I'm trying to find a
finding,
bug.
bro. You're finding.
Okay.
I think it's the return true.
This right here, right?
I think so.
So, uh,
No, we still have to return though.
but we don't have a true though.
Uh, okay, okay,
So
okay.
if I'm a say bool Ian, if boolean, wait, equals, dude, no, I don't like this, man. I don't like this. Like that, something like that.
Think so? Yeah. Oh, it's lowercase. No. Oh, you did a colon at the end of false.
Okay, so at least we know we're doing something wrong. Right, left.
It's because. Mm,
So let's see.
I go back. Let's
Number
see.
two.
So 1, 1, right?
1. If
None.
root is none, and root 2 is none, which
No.
is not. If root
No,
2
none.
or
Okay.
root 2 none, no, it's not. If root dot val, root 2 dot val, okay, yes. BFS root dot left, okay. So there's nothing on the second one. There's something on the first one.
Yeah.
So if root equals none and root, nope. This one,
Turn false. BFS. You know what we have to do? We have to return whatever we're being given because each call is gonna get a value, right? And like each BFS is gonna return a value. So we have to store those values either true or false, right? Because if you return false, it's not gonna go all the way. That false is not gonna go all the way up. It's just gonna go back to its parent call. So we have to do if BFS, right? Store those two values, right? Because it's gonna return false to the BFS call. Hold those values, in this case false, right? And then we're gonna do if statement. If both of them are not equal, right? That means that they're one's false, one is true, right? We return false, or else true, and that return is gonna go back up, if that makes sense. Because we're only returning true or false to the upper call. Yeah or nay?
All right, look, right here, look. How do I get to the, like, why is it like that? Like, it's right there. Okay, well, let me slide it. Oh, maybe it's a slider. Slide it. Nope, it's not a slider. How do we do it? You gotta extend it. But what if I want it like this? What if I, and then
We
look.
have the option to drag them over
Yeah,
here.
but why is that? Why do I have to drag it? Just let me just hit the arrow or something. Like I don't need. And look at this. Like whenever you got the arrows down
You
here
finally
now.
found the
Look,
bug.
here, go here. Oh, and let me just press the arrow again. Oh, the arrow's not there anymore. It's down here. Or let me like. That's just the this specifically right here. This little tab bar is not to industry standards.
Industry standard.
Yeah, it's not military grade tab bar, bro. I'm just saying. Like
I get you. I
at
get you.
least have it to where you could like move it or rotate whatever, scroll it right here. Oh,
Oh, oh, oh, oh, oh, oh, oh, oh. What'd you say? Scroll?
all right. I ignore
Yeah,
everything
bro,
I
you
said.
still trying to find the. Oh
Ignore
man,
everything I
bro, it's
said.
funny because every time you find something, it claps or comes back to you and tells you no.
Ignore
It's
everything
happened
I
like
said.
4 or 5 times. Okay,
I'm gonna figure it out. I'm
bro,
gonna find
it's
one.
gonna.
Okay, well, still this one though. This arrow, I don't know what's going on with that. I gotta go from here. In order to open back up, I gotta go down here. Like that's kind of.
Or you can click the arrows and drag the thing, drag
Or I could
the.
drag it, but like I said, not industry standard, man. Like I just want to hit the arrow. Hit the arrow where the same level I hit it at, not down here. And also, you don't even know where it's at. It's hidden. It's hidden until you go here. Oh, now you found it. Anyways, I'm sorry.
It's okay. It's
So
okay.
I know what you're talking about now. It's returning false, but it doesn't return false for the whole thing. It has to depend on the end. But my question was, before I got interrupted by this scroll wheel, is is wait. It's always wait. Isn't this always gonna return false?
Mm,
Or nothing at all?
think so.
Shouldn't we return? Okay, anyways. Dude, I don't
It's
know,
because
man.
all right. Let's see. Let's start from the top.
Yeah.
So it's gonna say none and none, and it's gonna return none. I feel like that should return true.
Do you think this should return true?
That should be returned true, right? So
Ah,
now we do if statement false and false. All right. So we're gonna do it's gonna do one and one, right? 1 and 1, they're blah blah, right? They're not none, none. Then 1 and 1, they're equal to each other. All right, let's go to the left children. Left children, 2, they're not none, blah 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 blah, right? 2, right? Then they're gonna go back up, right? 2, they're gonna go left side, right? Left side of 2 is none. Both of them are none. That's gonna return true. Right side of 2, right? They have both are none, so that's just gonna return true. So now 2, right? They're the same, so they have to return true to 1, right? Yeah or nay?
Yes.
Yes. So it's gonna return true to 1. So the BFS to the left, right? It's equal to true. Now we check the one to the right, and it's gonna do the same thing where it's gonna say, all right, none, blah blah blah, true. It's gonna return true, right? And here after that, it's gonna return nothing. Like you said, it's gonna return nothing because we're not have a default value. We have nothing, right? So I would say to store the values exactly val val 2 exactly, and then as soon as we finish the call outside the else statement and if statement, I think, right? Because now we have the values, we have everything. Yes, sir. We're gonna set return val equal val 2, or you can do it right there. Yeah, I think that works. Yes, and now let's run it with example 2, right? 1 is they don't have none, right? It skips the first 2 if statements, it goes into second one if, right? They have the same value. We go to the left side. 1 has nothing, 2 has 2. They go up, right? It skips the first one, then the second one, right? None, root none. No, it has 2. Root 2 equals none, right? So it's gonna return false. Now val equals false, right? Now we're gonna go to the left, right? 1 root on the left has nothing. Root 2 on the right has 2. We check them both up, right? And it's gonna return false. Now you have false, false. So we're gonna return, right? Okay. So that return, I feel like that return in line 29 is not good because it's gonna return true if they're both equal. We just have to return. We have to return if they're not equal.
No, it's gonna return false if they're not equal too.
Val equal. Hmm.
Yeah.
No.
Is this true? No, it's false. It returns false.
But it's checking if both of them are false, though. Is false equal to false? True. Wait a minute.
Wait. Can we check that?
Do you want to? Yeah. You can do imprint. Yeah.
Wait. Yeah, you're right. Because false
Yeah.
does
So we
equal
have.
false. So if
Yeah. Yeah. Pretty much. Yes. Mm-hmm.
wait.
No, because and is gonna check if both of them are true. If both conditions are true.
So then this would work.
Yeah.
Okay.
All right. So this is to my understanding. I don't know. I think I'm just talking gibberish. So we'll see. And I think you still have to return BFS. Return whatever BFS is gonna give you back. Yes. Come on, buddy. Let's go. Yes, sir.
Really nice.
Oh.
Let me just scroll real quick. All right, there you go.
But I think it's still bothering you, isn't it? Ooh. Oh, I'm scared for those, bro. Let's go.
Really nice.
Let's go.
Good stuff.
Let's go, bro. Oh, bro, that was a satisfying one. Damn, bro. I'm wondering how we solved it the other day. The other time we attempted this one. Submission. Oh, we did the same day. Okay. Oh.
Breadth first search. Looks very complicated, actually.
Oh. You know what we
We
did?
just we stored it, or
We stored them. We stored the
to the visited array, and then we said if those two visited arrays equal, then return true.
Yeah, return true.
Man,
I like
that's
this
the
one
baby
because
way. That's the baby
that's a
way.
baby way.
Look,
Come on,
we
come on.
saved
3
milliseconds
milliseconds.
of time. That's what we're talking about. All right.
Damn, bro, that's beautiful.
You want to explain that?
Yeah, for sure. So this is problem. What problem is it? I think it's 100. Yeah, problem 100, same tree, where we have to check if both trees have the same values at the same nodes at the same position and are structurally the same. In order to do this, we did a BFS. Well, no, not a BFS, a DFS, a depth. No, yeah, depth first search, right? So in order to do this, we did a pre-order where we checked the node, then the left node, then the right node, and we did a little small modification where we give it in two arrays where we are going to traverse in a pre-order traversal, in a pre-order matter, both arrays. And then within those both traversals at the same time, we're going to check if both values are the same, right? Well, first we're going to check if both values are none. If so, return true, right? That makes sure we're structurally correct. Return none if one of them is none while the other one is not. That's going to make sure if it's structurally incorrect, we're going to return true. And then we're going to check if the values are the same. If the values are the same, we're going to continue moving forward, right? And then we're going to return we're going to store the values of these two BFS calls into val1, val2, just to keep track of the if one side is false, if the other side is true. So we're just going to keep track of those values, so we can return if this particular subtree or tree is the same as the other tree, right? If they're not the same and stuff, we're going to return false. So this is a small modification we did where we traversed both trees at the same time, determine if the values are the same, they're in the same order, and if they're structurally correct. Yes, sir. All right.
Brilliant. So brilliant. Like always.
Nah, bro. This is all us. This is all us.
Where are we at?
Yeah.
Oh, so you know how we said like, oh, we only solved 62. That's because we're kind of repeating the same questions.
Yeah.
Like, so if I'm sure we could do like new ones, but since we're doing this right here,
so yeah,
we're repeating the
I
same
think
questions,
with
but
subtree we haven't done that one. Done that one nor the mediums. Yeah.
Yeah. But all right, man. I think.
All right, brother.
That concludes it. We didn't change our insane levels, which I feel like I should change mine after this one.
Let's do it. Let's do it. Yeah.
So, let's see. Let me just look at the problem real quick. So after this one, it kind of hurt me a little bit. I'm gonna say I'm like a ready to go type thing. So I'm gonna say like a. So the other ones, they kind of got me. They didn't get me as much. So I'm gonna say from the previous two problems, I was at a 2, right? I was at a 2, and now I'm probably like at a 6.
Okay, fair enough. Fair enough.
Yeah.
Okay. Okay. And I'm gonna say I'm at like a 3.
3.
3.8. 3 point
3.8.
something.
3.8.
Yeah, pushing 4.
Okay. Let me move that to the side. Yeah, I mean, I think I was doing good. The first two problems, I was there, I was ready, and then this one kind of messed me up, to be honest with you.
Yeah.
And I think you know, I don't want to give excuses, but you know, having a, you know,
Hey, it's
yeah,
all good, brother.
not
It's
locked
all
in
good.
enough. Like,
It's
so
all
there still
good.
could be other factors, but
Yeah, it's all good.
uh,
It's okay.
it's all good, man.
It's understandable. It's understandable.
All
All
right,
right, brother.
I guess that's it, man. That's
That's
it.
it.
We'll
Okay.
catch y'all next week. You know, got a
This
nice
is
little
this.
schedule.
Yeah. So everybody, that's thank you for coming in. Thank you for tuning in, commenting in the chat, subscribing. Make sure to share everything, all the things that you can. So you just make sure you have a great day, great morning, great evening, great night, whatever the time zone it is in your location. Just have a great, wonderful day. And if you got nothing to say, Carlos, I think we're good.
Yeah, I'm
Good to
good.
call it off here. All right. Well,
Yeah.
thank you guys and take care. Bye
Bye.
bye.